All right, here's a good example of where you, sorry, I had to shut my door, where you need to worry about sig figs in a couple of different ways. So the question asks for us to find the pH of a solution, but they give us a number of grams of hydrochloric acid, which would be a solid initially, and they're adding that to make a total of 1 liter of solution. So when I look at it, initially this has 3 sig figs and this has 2 sig figs. And so that's 3. So in my answer I have to go to the weakest link, so I have to go with 2. So watch how this happens when you're doing the normal calculations and then when you're converting it to pH. Okay, so first thing, I need to convert that grams to moles. So moles is equal to mass over molar mass. The mass is 10.0 grams divided by the molar mass of HCl. Oh, hydrogen's 101. Chlorine is 35, isn't it? 0.45, yeah. So it's 36.46. So 36.46 grams per mole. So when you divide those, you get 10 divide 36.46 gives you 0.274, 0.274273, etc. moles. Now I wouldn't do this because I'm not finished the question, but if I needed to round that to sig figs, it would be 0.2. I have to give 2 sig figs, so 0.27. Since that number is less than 5, this 7 stays alone. So if my question was done, that's how I would write it. Okay, then I need to figure out the concentration. So concentration is moles over volume. Moles are 0.274273, etc. Notice I'm using that whole number because I'm not done my calculation. So don't round as you go, round at the very end. Divided by the volume is 1.0 liters. You do that division, 0.274273 moles per liter. Okay, so that's my concentration. Now I have to find the pH. So the pH is equal to negative log of the hydronium ion concentration. But this one here is actually equal to the concentration of hydrochloric acid. So I probably should write my dissociation equation. So water or HCl dissociates in water to form hydrogen ions plus chloride ions. But since these are 1 to 1, and this is where I'm getting my hydronium, right? We said that hydrogen ion and hydronium ion, we sort of call them the same. They're not exactly the same, but for our calculations we can call them the same. But it's 1 to 1, so therefore this concentration that we got there of the hydrochloric acid is what I'm going to put in there. So pH is equal to negative log of 0.274273. I'll do my button here, so negative, where's my log button? Uh-oh. This calculator doesn't have a log button on it. Let me get a different calculator. It's got to have a log button somewhere, I just can't find it fast enough. Okay, negative log of 0.274273. Go. Okay, so this gives me pH of 0.56181, etc. Now, so the pH could have been some other number out front. This probably isn't the best example, but to figure sig figs for pH, you don't include a number out front. In this case, I'm not including the 0 anyway, but if that number would have been a 2.56, etc., this number here doesn't isn't included in the sig figs. It's only the numbers after the decimal place. So if I needed 2 sig figs, I'd need to give 2 decimal places. Okay, hopefully that helps you with that. Maybe let me just share one other quick example. So say I had a pH that was 4.392. So this is my pH, and what I want to know is I want to know the hydronium ion concentration. So the formula for that is 10 to the negative pH. So on my calculator I'll go 10 to the negative 4.392, and it comes out to 0.00004055085 is what my calculator gives me. And so what I need to do is round it to sig figs. In this pH here, although there's 4 digits, in pH only the digits after the decimal place count as significant. So in this question there's 3 sig figs. So in my answer here I have to round this to 3 sig figs. Zeros out front don't count, so I go 40. Since this one is 5 or more, I bump this one up to a 6. And that'd be my correct answer for this question, rounded to the right sig figs. You could also, of course, write that as scientific notation. All right, hopefully that helps.